Okay, so I can make this really tiny because Guess isn't here for us to see anyway. Okay. All right. So we were talking about relative motion in one dimension, okay, which is what you had some homework on. And we did that problem with the boy who was walking on the boat and looking at the boat and seeing how things were moving. And we can extend this to relative motion in two dimensions. Okay. And we know that with everything we have done and everything we will ever do in this class, that we can treat X and Y components independently. Okay, and that's really not gonna change. Okay, our drawing might be a little more complicated and we might think about a couple more things, but basically we can still look at the relative motion in X and then look at the relative motion in Y separately. Okay. So I'm going to consider two reference frames, and this is going to be my reference frame A, and it has X components and Y components. And then I'm going to consider my reference frame B. And I'm going to be concerned about an object at some point P. Okay. And just like when we went to two-dimensional motion, we replaced all of our X's with R's because that was the position vector. We can do the same thing here. So I can go from the origin in A to my point P, and I can call that R, the position of P with respect to A. And then from reference frame B, and I don't know what would be a good example of this, maybe P is a hockey puck that's sliding around on the ice. And there's a player A who's kind of sitting there, maybe moving a little bit. And then there's the Zamboni, which is B, okay? And they see the motion of the hockey puck differently, okay? But my Zamboni could also measure the position of that hockey puck, and that's going to be RP with respect to B. And the whole idea here is that I can measure the position of my Zamboni with respect to my hockey player. So that blue arrow there is the distance, the position from one reference frame to another. Dagny. The origins, yeah, because you assume that the origin is where the thing is, where the observer is. And then each of those observers located at the origin of their own coordinate system is observing this other thing and its position or its velocity or whatever. Okay. So just by looking at this and knowing your knowledge of vector addition, right? RBA and RPB are lined up tip to tail, right? So I could say that RPB plus RBA is going to be equal to what the resultant is. And remember that the resultant connects the leftover tail to the leftover tip. So what is that vector that connects my leftover tail to my leftover tip? Lauren? RPA. Okay. And remember that we had that kind of little trick where these inside indices should be the same when I was making a chain of things. So I would kind of say the position of P with respect to B plus the position of B with respect to A gives me the position of P with respect to A. You okay, Annabelle? Okay. With the mask, I can't tell. Okay. But because we can treat our directions separately, what we need to remember is this is really RPB, the X component, plus RBA, the X component, is going to be equal to RPAX, and that I can write a similar expression for the Y direction. Fiona. Yes, but understand that all of these would be I's and all of those would be J's. I personally would be more likely to use I's and J's up here when I was writing them as vectors, and then I pull out all my I's and set the I's on one side equal to the I's on the other, and the J's on one side equal to the J's on the other. Okay. So keeping in mind that velocity is really just the derivative of position, right? As we're learning in calc right now, then I can really say that VPB plus VBA is equal to VPA. Okay, because I'm taking the derivative of everything, and that's going to give me velocities. And then I can take the derivative again. And what's the derivative of velocity? Acceleration. So I can say that this is a PB plus a BA is equal to a PA. But we are making an assumption every time we do relative motion in this class. And what is that assumption that we make? Dagny, what do you think? That what? Yes, I'm sorry, yes. But beyond that, an assumption that is specific to relative motion. Annabelle. No, but it's something about the frames. Lauren, what were you going to say? We don't actually. We are not actually assuming that acceleration is constant. It doesn't. Yes, that was for chapter 2, but for relative motion, we don't have to make that assumption. if you want to use if you want to apply the chapter 2 equations to relative motion, then yes, you have to have constant acceleration. Sophie. I mean, the axes would have the same units probably, but that's not it either. Lauren. Would it be that they're both in the same positive direction? Nope. Nope. Tia. Yes. So what we assume is that VBA here is equal to a constant. Okay, that the reference frames are not accelerating with respect to each other. So if my hockey player is standing there watching the puck, the Zamboni is moving at a constant speed and velocity with respect to the hockey player. Okay, which means what about the acceleration BA? What about this term? It has to be equal to 0 because my reference frames aren't accelerating with respect to each other. Okay. And again, these two equations here can be written separately for X and Y. Okay, so each of those is really 3 equations, 1 for X, 1 for Y, and 1 for Z. But relative motion is complicated enough that there's no reason to make it be in 3 dimensions, unless you're in outer space. And then you have a whole nother set of problems. Okay. All right, we good? Okay, then let's try the example problem, right? You have it written in your book, right? Or in your notebook? Okay, what is it, example 2? And it should say ship A is located 4 kilometers north and 2.5 kilometers east of ship B. Ship A has a velocity of 22 kilometers per hour south, and ship A has a velocity of 40 kilometers per hour in a direction 37 degrees north of east. What is the velocity of A relative to B? Should be in your OneNote notebook. Class time. The same place that that problem was about the boy that we did on whatever day that was. Okay. You can always go up to the content library and copy the problem out of there and paste it into wherever you're taking your notes right now. It's okay, but that's just an easy way to solve it. Okay, so what should we do first? Draw a picture, okay? And because I want the velocity of A relative to B, when I draw my picture, I'm gonna put ship B at the origin, okay? And I'm also doing that because I'm told where ship A is with respect to ship B. And I could put ship B someplace else, but why make my life complicated? Okay. And then we're gonna let this be I or east and J or north. Okay. And then I'm going to go 1, 2, 3, 4 kilometers, 1, 2, 3 kilometers. And I know that ship A is 4 kilometers north and 2.5 kilometers east. So there's going to be ship A. There's another part of this problem where you're supposed to figure out like when they come together and all this jazz, but we're not going to do that. So that's kind of why you need to know where the ships are. Okay. And then I know some velocities, right? So how is ship A moving? Okay, so it's going to be moving south, so that's the direction of my arrow. And what is that measured with respect to? It's always measured with respect to something. Dagny. We're going to say the water, okay? And that's going to be negative 22 kilometers per hour J. And then how's ship B moving? Okay. Yep. Okay, so north of east means I start east, I move that number of degrees north. Okay. And we'll call that VB water. And then VB water, it's not along any of my axes, right? So what do I need to do? I need to find the components. Okay. So I know it's 40 kilometers per hour. So what do I multiply the 40 kilometers per hour by to get my I component or my X component or my east component? Dagny. Yeah. And that's going to give me I. And then what do I multiply it by to get my J component or my north component or my Y component? Fiona. Yeah. Sine 37 degrees. Okay, and those have numbers. I don't care what they are at the moment. I might care later. Okay. And then what do I want to find? What's my find statement here? What do I want? Velocity of A with respect to B or relative to B. Okay. So I know the velocity of both of those things with respect to the water, but now I need to figure out what they are with respect to each other. So what kind of an equation or a statement might you write down that would have the things that I know, VAW and VBW and VAB in them? Dagny, what do you think? Okay. Lauren, you want to try? I don't need to make anything negative right now. Well, I might eventually. No, I don't need to make anything negative. I can do it without making things negative. Yes, but let's back up a minute and just make a statement that follows the rules we've been following about those interior indices. Okay, still not where I want to go. An important point that I'm going to make in a minute, but I'm not, let's take the pressure off for a minute. Don't say that equals something. I just want an equation that has it in it. Sophie. Sure. Okay, so that works. Okay. And then I can solve this for VAB is going to be equal to VAW minus VBW. Now, the thing about this is that I know everything, right? And I know how to subtract vectors, right? Now, what Lauren was saying, which is actually important, is to say that VBW is equal to negative VWB, okay? Which makes sense if you think about it. If Fiona and I are walking towards each other and she measures my velocity as positive 3 meters per second, I'm going to measure her velocity as minus 3 meters per second, okay, when I take our velocities with respect to each other. Okay, so that's just something to remember. I have a feeling you might need it for the homework, but I don't know exactly. Okay. So that's just something to keep in mind. And you can do this. Okay, there's nothing wrong with that. If it makes it easier when you're solving a problem, that's cool. I'm not going to use it here because I know what VAW and VBW are. Okay. So now I just want to, I can do this by components. I can do it separately. Okay, so I could look at VABX and say that that's going to be VAWX minus VBWX. And then I can say that VABY is going to be equal to VAWY minus VBWY. Okay, we're good? All right, so I believe that VAW doesn't have an X component, right? Because it's moving south. So I can just get rid of that, which tells me that VABX is equal to 40 kilometers per hour times cosine 37 degrees, right? And VABY, if I just substitute everything in, gives me what I believe this is negative 22 kilometers per hour minus 40 kilometers per hour times sine 37 degrees. Yes? So what do we got? Oops, I forgot my minus sign up there.
Why would you have a minus sign?
Because of my algebra, there was a minus sign here. No, it's okay. I forgot it too. And I'm looking at my answer going, where, oh yeah, yeah. So what'd we get? What'd you get, Lauren? No, VABX, that's what I want to know. Okay, so but remember that there's this negative sign, okay, in the X because of the algebra. Okay, I forgot that. Minus 46, whoops. Kilometers per hour, J. Okay. All right, fair enough. Okay. Then what I would like to do with the remaining 18 minutes is to finish the projectile motion lab design. So does everybody have their lab designed? Okay. So write it out. Tia and Lauren, you were a group, right? Is yours done? You need to talk about it? Okay. Sophie, who were you working with, Fiona and Guess? Okay, so you guys still need a little work? Okay, so what I would like you to do is your write-up needs to be done by the time you walk into class tomorrow morning. Okay, and then we're gonna swap. And then hopefully we'll do the experiment tomorrow. Okay. If not, we'll have to do it on Thursday. Okay. So get into your groups, work with your groups, figure stuff out. I am going to stop sharing and stop recording. Oh, one more thing though before I stop recording. I was able to insert the video that I wanted to for part of the chapter 5 stuff. So you can download what you're supposed to read for Thursday anytime you like. Okay. I still have the video I want to record for the stuff that comes in the next assignment, but I haven't really assigned that yet. For what? Uh-huh. Because there's a negative, oh, hang on. Because there's a negative sign right here because of the algebra, and that negative sign doesn't go away. It's VAW minus VBW. So even though the X component of VBW is positive, there's a minus sign in front of it, so it becomes negative. I don't know how else to make it any more clear, but that's where that comes from. Okay, you good? Okay, good. What? I think so. Well, and you had to have like a list of the things you were going to measure, right? Like you needed a list of your equipment. You needed to like identify your variables, I thought, and name them. So I'm going to measure this, and this is what I'm going to call it. There should be a list of what you need to do. I don't remember all of it, but